you can see these two diagrams. In the first diagram, light ray is passing from one transparent medium to other transparent medium, but there is no deviation. The path of the incident light ray and path of the refracted light rays are same. It is possible when the speed of light in both of these two mediums are same, which is possible only when the refractive index of these two mediums are same. And the second condition is if the light ray fall on the interface normally, then it will pass undeviated. In that case, the angle of incidence is 0 degree. So these are the two conditions for the light ray to pass undeviated. Now let us see the relation between wavelength of light in two medium. As earlier we have discussed that when the light ray refract, then the parameter which do not change is frequency, and V and lambda changes. So suppose this is the transparent medium, and in this transparent medium the light ray refract. Suppose the speed of light in this medium is c and the speed of light in this medium is v, and frequency of the light is f. Both in the incident and refracted light ray will have same frequency because frequency depends on the source. Let us assume lambda 1 is the wavelength of light in this medium and lambda 2 is the wavelength of light in this medium. Let the refractive index of second medium with respect to first is mu is equal to mu. We call it refractive index of second medium with respect to first, and let it is mu. So for the first medium, we can write C equal to F into lambda 1. Say this is equation 1. The speed of light in first medium is taken as C. Frequency of light coming from a particular source is F, and lambda 1 is the wavelength of light in this medium. Similarly, V is equal to F into lambda 2. That is equation 2. Here V is the speed of light in the second medium, F is the frequency of light coming from the source, and lambda 2 is the wavelength of light in the second medium. If you divide these two equations, then C by V equal to F lambda 1 divided by F lambda 2. Cancel F, so that is lambda 1 by lambda 2. Now, all of you know that the ratio of speed of light in air to the speed of light in any material medium is equal to refractive index of second medium with respect to first. So that is equal to lambda 1 by lambda 2. We assume that the refractive index of second medium with respect to first medium is mu. So we can write mu equal to lambda 1 by lambda 2. Therefore, lambda 2 equal to lambda 1 by mu. It means if you divide the wavelength of light of the first medium with the refractive index of the medium, then you can get the wavelength of light in the second medium. Next, we are going to discuss principle of reversibility. Suppose this is a transparent medium. This is one incident ray. This is the normal and this is the refracted ray. Let inside this medium we are keeping a plane mirror normally. Let us assume this is water, say, and this is air. Light is coming from air to water. Water is denser than air, so the light is bending towards the normal. Suppose the refracted light ray is striking normally to the plane mirror. Let this angle is theta and this angle is phi. Let this is medium 1, let this is medium 2. So medium 1 is air and medium 2 is water. When the light ray travel from air to water, here we are considering two refractions. First refraction is air to water. If we consider refraction of light from air to water, angle of incidence is theta, angle of refraction is phi. First medium is air and second medium is glass. Second medium is glass. So according to the law of refraction, you can write refractive index, not glass, this is water. This is water. So refractive index of water with respect to air, it is sin I by sin R. That can be written as sin theta divided by sin phi. Say it is equation 1. Now let us consider the reverse refraction. In the reverse refraction, the refracted ray reflects back through the mirror and becomes the incident ray, and it will be found that the previous incident ray now becomes a refracted ray. That's why it is called principle of reversibility. So for the reverse path, when the light travels from water to air, in that case angle of incidence is phi, angle of refraction is theta. First medium is water and second medium is air. Second medium is air. So according to the law of refraction, again we can write refractive index of air with respect to water equal to sin phi divided by sin theta. This is equation 2. Now if we multiply equation 1 and equation 2, then what we get? Equation 1 into equation 2, it gives refractive index of water with respect to air into refractive index of air with respect to water equal to sin theta by sin phi into sin phi by sin theta, which is equal to 1. So principle of reversibility states that the refractive index of water with respect to air multiplied by refractive index of air with respect to water result 1. Or we can say refractive index of water with respect to air is 1 by refractive index of air with respect to water. So let us take an example which explain this principle. If we say refractive index of glass with respect to air is 3 by 2, then according to principle of reversibility, refractive index of air with respect to glass will be 2 by 3. Second example, you can say if the refractive index of water with respect to air is 4 by 3, then refractive index of air with respect to water is 3 by 4.